Determine the integral of the following function. X ln. Oh, lawns. Who uses lawns? Anyways, okay, so can I take the integral of this straight up? No, I don't know what the integral of that thing would be. So can I use it by part, or no, by substitution? Do I see the derivative of the inside outside? I don't, because the derivative of x is 1, and I still have an x out there. So I'm going to have to use by parts here. So let's use by parts. So let's pick something that's going to be simpler. Remember, the integral, or the equation for by parts is this. The integral of u dv is equal to u times v minus the integral of v du. So what am I going to choose for u? I'm going to choose something that's going to be simpler, the x. And for dv is going to be that guy. That's going to make it, that's going to be the rest. Well, hopefully that works out. So let's write it down here. So u is equal to x. So du is equal to dx. Therefore, there we go. And then dv is equal to ln of x dx. So we need to integrate that, and I'm embarrassed to say I don't know what the integral of ln off the top of my head is. I'm going to have to look it up, and there I am. It's going to be, wow, it's a little complicated. It's x ln of x minus x. That is the integral of ln dx, okay? So you look that up. That's a base function, no problem. So you look that up, you got your stuff. Okay, let's put it in here. Doesn't look very much simpler, though. Anyways, let's shove it in here. So it's going to be integral of y dx is equal to, oh, we have our parts here. This was u, and this was dv. So now we can put in is equal to u, which is x, times v, which is x ln of x, minus x, bracket closed, minus integral of v, oh, which is x ln of x, minus x du, which is dx. Whew. Let me write this down. I'm going to separate this integral into two separate ones, because I can already separate it into two. So it's going to be the integral, and instead of me putting y here, I'm going to put the original integral, because that's what I'm actually integrating, right? So the integral of y ln of x dx, this is equal to x, let's expand all this out here. So x squared ln of x minus x squared. Okay, and we have minus x, integral of x ln of x dx, and then minus minus is going to be plus integral of x dx. Okay, it did not make it simple. Well, this one's okay, but this guy right here is not as simple. It is in fact the original integral. So I included this one because I love this type of equation, okay? So what we're going to do here is solve this thing, because I could just recursively keep on doing this. I could just be, I could do it again. I could be like, oh, okay, well, let's do it by parts again. But I would come to the exact same conclusion. So what's really cool about this is, here's an equation. Let's solve for this. This is what we're trying to solve for. So I think this is really cool here. What we're going to do here is we're going to add integral of x ln of x dx to both sides, plus integral of x ln of x dx to both sides. So that will cancel this one. This minus plus cancel, cancel. And over here I'll be left with 2 integral x ln of x dx is equal to x squared ln of x minus x squared. And now this guy, I can do this one. This is going to be plus 1/2 x squared plus c, right? And that's that, yep. And now I have to divide by 2. So the final solution for this integral in a roundabout way is equal to 1/2 x squared ln of x minus 1/2 x squared plus 1/4 x squared plus c. I don't have to divide c by 2 because it is already just a constant. We don't even know what the number is. So the number divided by another number, we can call it b, but it's still a constant. So I'll just keep it as c. So don't get confused by that. I didn't divide c. We'll call this small c. We'll call it c1, and we'll just call that c, so everything works out just fine.